In this video, let's quickly review what we've been talking about during this section of content. So first of all, right, we've learned what is the lower bound for sorting. So lower bound for sorting is, of course, n log n. Right? So no sorting algorithm can do better than that time. Because we know that, we now know that merge sort is asymptotically optimal, right? So there's no way to have something that's log n, right? Something faster than it. Okay, so merge sort, good to go, right? It's great. It's a wonderful algorithm. We'll keep it around because again, it's fast. All right, this is a nice result, right? So now, right, instead of having somebody, in the basement somewhere, right, some poor PhD student, trying to get this faster sorting algorithm, they can now stop, right? We already have one algorithm we have several algorithms that already touch this n log n, that already are, at the lower bound. Nobody else really needs to go and invent something else, right? So that's a very nice thing to have. Now some observations about what we talked about. The first thing is that when we went through our proof, right, we did the decision tree and all that other stuff. The only real assumption we made about the problem or the algorithm is that it was all comparison based. So we did have this little operation where we said, okay, this is whatever is at position 0 is less than position 1, and we did do that. Okay, that's the only thing, right? We never talked at all about Java. We never talked about low sort architecture. We never talked about anything related to our actual hardware. We just did it on comparison. Okay. And this is very, very important because we're not bound to a specific programming model anymore, right? This result isn't just for us right now, it's kind of a permanent result, right? This is a result, relies only on assumptions coming from the problem itself, right? The problem of sorting an input pool of data. And so what we're saying, right, is that, hey, anything out there, right, any other programming language, any other computer, anything else, right, will never be able to, do faster than this, right? That's the point of a lower bound proof. We have a proof on the structure of the problem itself, so the claim we make, right, that this is as fast as you can get, will hold permanently, right? It's not contextual, right? This is the real result. We can never do better than this, right? The proof is on the structure of the problem itself. All right, so actually, and I'll just read this text here at the end, right? So this is kind of our summary here, right? As long as compares are the optimal way to sort, one cannot build any computer or write any algorithm to do general sorting in less than n log n time. Okay, that's our final result. And that result is very, very strong, right? Notice I have the words here, any, very strong, right? So no matter what you do, right, no computer you build, no matter what algorithm you come up with, right, in all the millions of years to come, you will never do better, okay? And that to me is nice. It's a little bit comforting to know that right here and now, we do have the very best there will ever be. All right, so that's it for merge sort and our analysis of algorithms. Again, right, this is kind of a nice unit in terms of we've talked about a very nice, fast algorithm, right, with conceptually simple to explain, and also talked about how it is, in fact, one of the best sorting algorithms that could ever be written.